All right, let's talk about the constant of proportionality and its relationship to what we call slope as well. So just to be clear, a lot of times those can be used as one and the same, but the important thing, remember we talk about direct variation, is that it has to cross through the origin. So right here, you see that this goes through 0, 0 right here. So the slope will be the same as the constant of proportionality. And remember, in order to find slope, let's talk about what slope is. Slope is the change in y over the change in x. And another way we talk about that is rise over run. So it's actually really simple to find this when looking at a graph. You'll just count the rise and then the run. And remember, you always want to find a value that intersects those crossing points on the grid. So for example, I'm going to move from here and I'm going to rise 1, 2. And also look at your scale. In this case, it goes by 1, so I know that's 2. But if it was going by 2s, that even though it was 2 boxes, it could have been 4. All right, so rise is 2. And then I'm going to run 1, 2, 3, 4, 5. And see how now that gets to a point of intersection right there? So I have my rise over run. My rise would be 2. And my run would be 5, which means my slope or constant of proportionality here is 2/5. Okay, and could that simplify to a decimal? Yes, technically it could, but let's leave it in the form of the fraction for this. All right, typically when we'd ask you to simplify it all the way is when you can simplify that fraction, but in this case you can't. All right, so now it also asks us to write an equation for this line. So remember, whenever we're given the constant of proportionality, we know that the equation that matches up with that is y equals kx, where k is equal to the constant of proportionality. And if we know that's true, we know this is the constant of proportionality. Can't we just plug this in the place of k and then have our equation? I think so. All right, and let's talk about what the slope means in the context of this problem. So what does this tell us about this problem? Remember, you'll just read off the axes and what they're labeled. So this would tell us vans. So for example, when I'm getting 2 vans, I'm going to look where this intersects right here. Then how many Converse am I getting? That's something it might tell you, right? If I'm getting 2 vans, I'm getting how many Converse? All right, hopefully that helps you with this problem. Please join the live if you're still struggling.